All right, page 4. So we're going to graph this rational function. All right, it's actually called a reciprocal function, but I like to call it rational because rationals are the ones with the division or fraction line. So anyways, to graph this, we need the asymptotes. The asymptotes, and remember we find that from our denominator here and from the number outside here. So the one that's in the denominator next to x, remember x is a liar, so that line would be not positive 4, but x equals negative 4. So I'm going to draw a vertical line at negative 4, where x equals negative 4. And then the other one is the y, and y does not lie to you, so it actually is negative 2. Y equals negative 2, that is a horizontal line crossing negative 2. All right, and now reciprocal functions, they will be really close to the line, and then they'll come back down to the other line here on the top right, and then they get really close and then they go away from the line, but then they get really close to the other on this side, and they'll have little arrows on the end. Okay, so you'll always have a line in the top right and the bottom left. Now let's just say that we had negative 1 here, or there was just a negative in front of the function. How that's going to change, let's actually use a different color. Let's just put an orange negative here. We're going to put orange negative. If that was negative there, what would happen is that this line up here would move down, and this line down here would move up. And so you basically would have one in the top left and the top right. I mean bottom right. Okay, so it basically just flips if you have a negative. Okay, because you may have to match a graph on the test. Okay. All right, so now this next one here, this is solving rational equations. Now what we want to do here is we want to get rid of the denominators. Getting rid of denominators makes life a lot easier. So I'm first going to spread this out. It makes it a lot easier because we're going to cancel out all these denominators. So if I spread it out, it makes it easier to work with. All right. So I'm going to go ahead and factor out the denominators as well. So there's not much I can do there. So with the 8x and 2x, so I'm just going to spread out this x squared so that I can kind of show you what I'm doing. All right. So what I want to do again is cancel out the denominators. To do that, I'm going to go from one rational to the next and multiply what's below. So here, to get rid of this 8x, I'd multiply 8x. That cancels the 8's and cancels the x's. But of course, if I do that, I have to do it to every rational. So I have to do it here and here. So now 8 over 2, they cancel, and then we still have, it leaves us with 4. And then the x's will cancel. And then here the 8 does not cancel because there's no number on the bottom, but only one x cancels. So the problem is I still have an x for this rational here on the right. I still have an x, so that what that means is I'm going to have to multiply an additional x to each one more. Okay? And that will cancel out that. So now what I'm going to do is whatever's left on top, I'm going to multiply it or just bring it down. And in this case here, I have a 1 and an x, so 1x. Okay, here I've got a 1, a 4, and an x, so you multiply it. 1 times 4 is 4, times x, 4x. And then minus. And here I've got 1 times 8. That's all I've got, so just 8. And hey, look, that looks like a lot easier to work with, right? So let's subtract the 4x from both sides. Negative 3x equals negative 8. Divide negative 3. Positive over a negative gives us a positive 8 over 3. Okay, and there's our solution. Find the one that in the choices on multiple choice. All right, simplifying radicals. Birthday cake, birthday cake, birthday cake, birthday cake, birthday cake. So take that number inside. First, we're going to birthday cake. All right, so remember, choose the smallest prime number. Don't just choose any number, smallest prime number, okay, which is 2. If 2 doesn't work, then use 3. 3 doesn't work, then use 5. All right, so we're going to divide that by 2. Let's see, that will give us 64? 64. All right, I can divide that also by 2, and that gives us 32. I can divide that by 2, and we'll keep on going with the 2's until I can't do 2 anymore. Sorry, I'm running out of space here. 2. Actually, oh, I can move this down a little bit. Watch this. Ooh, magic. All right, so divide the next one by 2. So 2 again. And then guess what? 2 divided by 2 is 1, or the birthday cake candle. All right, so, and then also, so I'm going to rewrite this radical. So first thing, before I start working with those 2's, if you have a negative inside, you can simply move that negative outside. If this is an odd index, like 3, 5, 7, you can just simply move that index outside. So that's all we're going to do there, okay? I'm going to spare my breath in teaching why and just tell you to move that negative outside, all right? Don't leave it there. Move it outside. The next thing is we pay attention to what the index is, which is 3. I'll zoom in a little bit. And so we're going to circle groups of 3 in our birthday cake. So there's a group of 3 2's, there's another group of 3 2's, and we only have 1 left. So for every group of 3 2's that you circle, that will come outside. 1 will come outside of the radical. So I had 2, so 2 2's come out. And then the x's here and the y's, I have 7 x's. So how many groups of 2 do I have in 7? Well, I've got 1, 2, 3. So that means 3 x's come outside, or x cubed, and I still have 1 inside. Oh yeah, let me put the 2, because we have 1, 2 left over there. And we have 1 x left. And I have 2 y's here. That's not even a group of 3, so the y's will remain inside. All right, so don't forget your index. And then simplify if you can. I have this 2 times 2, so we'll have negative 4 x cubed. And then the cube root of 2 x y squared. Okay? And another way of doing that is simply, I can do 7 divided by 3 is 2. So then 2 2's come out. I'm sorry. I totally did that wrong. I'm sorry, guys. Some of you guys are like, wait a minute, it's a 3. Thank you. So 7 x's. All right, so it's actually groups of 3. So that means I need to circle groups of 3 here for the x's. So there's only 2 x's that come out. So not x cubed, but x squared. Sorry about that. For any freaking confusion that caused. So again, what I was trying to say is that if I do 7 divided by 3, that's 2. So that's where the 2 comes from. And then the remainder is 1, so then there's still 1 inside. And then 2 divided by 3, that's a fraction, and it's a decimal, so I can't do that. All right? So there is, and don't my expression. And don't forget the negative, bring it outside. Okay? Next one. 2 radicals being multiplied. Now I could combine these radicals as long as the indexes are the same, but they are not. So I'll have to do each radical separately. So first I have 7 x's here, and the index is 4, so 7 divided by 4 is 1. So only 1 x comes out, but the remainder is 3. Okay. And then the next one, 10 divided by 5 is exactly 2, so I will have none left inside. I will have 2 x's that come outside. Now, to simplify it further, the only thing you can combine here is any x terms that are outside of the radical. So this x to the cubed, I can't multiply it times x or x squared, but I can multiply the x and the x squared, which become x cubed. I still have x cubed inside, and then don't forget the all-important index from that radical that's still standing. Whoop. Okay. Next, down here, we're going to skip this one, please. Don't do that. Don't worry about it. Not on the test. All right. Another one of these radical equations. Remember, we need to raise this to the power of what? Think about it. If you guessed it, 4. Okay, whatever the index is in the front of the radical. Okay, so that all that does on the left is cancel it. And on the right, we actually have to raise 3 to the power 4. 3 to the power 4 is 81. Okay, how do I know that? Because I've done this problem like 100 times. So I already know what 3 to the 4 is. All right, so cancel out the 1 there, and x is equal to 80. Boom! Dynamite. All right, so next one. Given the measurements, solve the triangle. What does that mean? It means find all the sides and find all the angles. All right, well, I'm going to start with the easy one. I notice that I've got 2 angles already. All triangles, the angles all add up to 180. So if I can take the sum of those 2 angles and find the difference of 180 in that sum, then I can find the angle. So I'm going to add these 2 angles up, 36 plus 83, and I'm going to subtract that from 180, and that should tell me the angle. Okay, so 36 plus 83, that's, let's see, 113 plus 6, so that's 119. I believe. So, right, let me just double check real quick. Yep, okay. And then, so subtract that from 180, and then we get 61. Okay. So then that missing angle there is 61. So now all we need to find is C and V. All right. So what I notice is that I don't have a right angle, so I can't use the 4590, or I can't really use just sine, cosine, or tangent here. I have to use what we call the law of sines. As long as I have an angle and its opposite side, I can use the law of sines to figure out any missing sides or angles. All right, so I'm going to look for C first. So what I do is I put C on the top, and then I put its opposite angle below, and I take the sine of that angle. And remember, sine only goes with angles, not with sides. And again, let me repeat, I'm putting whatever I'm looking for, I put that on the top. So C goes first. Then I have to do the same ratio on the other side, or same setup. So if I put side on top, I have to put the other side on the other numerator. All right, so now I'm using the pair that I know. I know this pair because I know 83 and 29, so that goes on top. Then I do the sine of 83. All right, and so if you guys remember, I just cross multiply, but then the trick here is just, if I have C over here on the top, I can just take sine of 61 and move it up here and save myself some steps. And I'm going to go ahead and enter this in the calculator. So I'm going to pause the video and go ahead and enter it in the calculator. If you don't know how to do it, ask me. Or you could ask a friend. So I went ahead and just did that in lightning speed, just because I paused the video. All right, and it says to round everything to the nearest tenth. So we're going to round our 25. I'll show you if I can on here. It probably doesn't show up very well on the camera there. No, it doesn't. Oh, you can kind of see it. All right, there's my 25.55, and that rounds to 25.6. Degrees, please put degrees, and don't put like the measure if it was like meters, because we're looking for the angle. Oh, I'm so sorry. I just said that out loud, didn't I? We're actually looking for the side. I apologize. So don't put the angle, and there's no units, so just leave this 25.6. So 25.6. All right, and now we want to find the other side, V. So basically, we set up the same ratio. So why don't you go ahead and try to do that on your own? Okay, try to set up the ratio the same way. Remember, V goes on top, equal to the one that we know. So I'll go ahead and let you try to do that. Okay, so again, set up that same ratio. Again, it's V over its opposite, the sine of its opposite angle, and the opposite angle is 36. So, and then we use the ratio that we know, or the pair that we know, which is 29 and 83. It's the same one, and we're going to use cross multiplication and bring the sine 36 up to the top, and we'll just simply enter that in the calculator. So I'm going to pause the video real quick to enter that in. Oops, sorry, that's not sine 36 on the bottom, it's sine of 83. Don't make that mistake. Okay, like magic, I just came up with that in my brain. No, I did not really use the calculator. So 17.17 was what we came up with, so that rounds to 17.2. And then there's our other side. And again, if you're having trouble entering that in the calculator, just ask me before the test or ask a friend. All right. So number 30. All right. Hey, look, another radical equation. Again, same steps. Raise it to the same power of that index, which is 2. Remember, it's 2 if there's nothing there. Okay, so this one gets kind of fun. All right. So again, if we raise it to the power 2, that just cancels the radical. So I'm going to kind of make some leave our room some space here, because this one will be a little bit longer. Okay, so that cancels the radical, so 2x plus 14. And then if you notice here, we're not just squaring just a number, we're squaring an expression, a binomial expression. And so what that means is now I have 2 of them. So that means we have to FOIL that, or use the box method as I taught you guys before. You know, it's up to you how you want to multiply this. So you can do FOIL, first times the first, multiply the first, and then the outside, the inside, and then the last. But I like the box, so I'm going to do x3 here, x3 here, x squared, 3x, 3x, and 9. And all I'm doing is multiplying everything. So the first term is x squared. And remember, the diagonal always adds up, so plus 6x, and then plus the last term, 9. All right, so here's what you need to look for, whether you're doing solving rational equations, like, let me see, where's the rational equation that we just did? Like number 24, or whether we're doing these radical equations, is that if I end up with x squared in the equation, that signals to me that I need to move all my terms to one side and set this equal to 0. Okay, because then we're basically looking for the roots or solutions or of a quadratic. Whereas in the other case, like this, in number 28, when I raise it to the power of 4, I didn't get a quadratic or a squared term in the equation. So I could just solve it linearly by taking away from each side, isolating x. Okay, so again, if I get x squared, move everything to the side where x squared is. Again, if x squared is negative, however, you want to move x squared over to the other side so it becomes positive. Or just multiply everything times -1 to cancel it out. Okay, so first we're going to cancel out this 2 by subtracting it. Subtract it from there, and also cancel out this 14. Cancel it and take it away from its like term. So now I just have 0 here. X squared, 6 minus 2x is 4x. 9 minus 14 is minus 5. And now to find our solutions, our roots, is we're going to factor this. Okay, so you can use your x or whatever method you'd like. This will be x and x, 2 numbers that multiply to -5, add up to 4. That'd be 5 and 1, and it's positive 4, so that means the bigger number, 5, has to be positive. Okay, so remember x is a liar. So if this is x minus 1, then our first solution is x equals 1. And then if the second factor is x plus 5, then our solution is x minus 5. Now, more often than not, one of these solutions will not work. So you're going to have to plug them in, like I did in the last problem, and check to see if they work. Okay, I think in one problem, actually the last one, I did not check, so that was not good of me not to check. So I should have plugged this 80 back in. Let's do that really quick. Okay, so 80 plus 1, and we'll go back to the other one in a second. And then 80 plus 1 is 81, and the fourth root of 81 is equal to 3. And you can plug in the calculator if you like, just to double check and check that. If you don't know what the fourth root of 81 is, well, it happens to be 3. If you don't know how to put that in the calculator, ask me as well. Or go on YouTube, actually. Look up, how do I find the fourth root of a number on my iPhone or my Android? All right, so now we're going to have to do that with each one of these, because, again, when we get 2 solutions, most likely one of them is not going to work. So I'm going to first take the 1, plug it in here. All right, so 2 times 1 is 2. Oops, sorry. There's an x term over here, so that means I also have to plug that 1 in, or 1 over there. I plug in the 1 over there as well. So 1 plus 3 is 4, and 2 plus 14 is 16. The square root of 16 is 4, so that one's good. So 1 is a solution. So there's a good chance, there's probably this one's not going to work. All right, so, and who knows, I might be wrong. So now 2 times negative 5 plus 14, all right, is equal to negative 5. I'm about to eat my words. I think this does work. So 2 times negative 5, that's negative 10 plus 14. Negative 5 plus 3 is negative 2. Actually, it might be wrong. All right, so negative 10 plus 14, that is positive 4. And we all know that the square root of 4 is not equal to negative 2. So we're not accounting for the negative solutions. Boom. So that, oops, sorry, it's not a check. That is not a solution. So that means the only solution here is x equals 1. So make sure with these radicals equations, you guys are plugging it back in, okay? All right. What are the coordinates of the vertex of the parabola of this equation? All right. So this, if you guys remember, is called vertex form of a quadratic, of the parabola. The parabolas, remember the U's like this. All right. So in vertex form, it actually blatantly shows us the vertex right there. That's why it's called vertex form. Because remember the first number inside the parentheses, that's our h, but also our first x value for the vertex, 1. And x is a liar, just like in that one reciprocal function. So if it's x plus 1, it's negative 1. And if it's outside the function, or sorry, not outside the function, but outside the parentheses, it stays the same. All right, negative 5. So that's the vertex. So if I go back to this top left over here, remember here where I said x plus 4, x is a liar, so it's actually x equals negative 4 for the asymptote. Same idea. X is a liar. Anything next to x is always lying to you. Okay, that's it. We'll go to page 5.